Hello everyone, how are you going? So today we are doing similarities, which is part of the geometry unit that we are learning at school. So let's get started. So the first thing that we are considering is similar shapes. So if we look at the figures below, so the figure on the left and the figure on the right are both similar shapes, and that's because they have the same shape but of different size. Yeah, so if I actually join the corresponding points together, the lines will actually converge at a single point. So this looks like the second figure is like an enlargement of the first figure. Yeah, and because of that, we can see that I actually generate these angles using f of x, and we can see that the corresponding angles have the same value as well. So this acute angle over here, it has the same value as this acute angle over here. And the reflex angles are also the same. It has the same value. And the right angles are also the same. So this means that similar shapes actually have corresponding angles which are equal. So another feature to consider about similar shapes is that if we look at the height of the first figure over here, so the height here is, I've drawn this on the grid so we can see that this is actually 4 units, and the height for the second figure is 8 units. The base length of the first figure is 1 unit, and the base length of the second figure is 2 units. Yeah. So we know that corresponding sizes are proportional. So for similar shapes, so we can see that the left sides are proportional, the bottom are proportional, and if I want to calculate the slant heights, they will also be proportional. So to find the scale factor of this similar shape, we need to use this formula over here, which is image length divided by original length. So let's say in this situation, my image is the bigger figure over here, and the smaller image is the original one over here. So if we consider the left side of these shapes, yeah, so the 8 is the image length divided by 4. Or if we consider 2 of the corresponding lengths over here, which is the base, which is 2 here, divided by 1, they will have the same scale factor, which is 2. So this means that the two shapes are proportional. Yeah. So what about figures 1 and 2 over here? Are they similar? So yes, they are. It's just that I have rotated this one to look like it's a little bit different. But if you rotate the first figure back by 90 degrees, they are actually similar shapes. Yeah. So another thing to note is the symbols for similarity. We actually use this symbol with the 3 vertical lines, or we actually use this symbol over here. So in to write an expression about this, it means that figure 1 is similar to figure 2, or figure 1 is similar to figure 2. Yeah. So another thing that we need to be doing is to do a similarity test. So if we want to find out whether the first triangle is similar to the second triangle, we have to perform a similarity test. So we can use different methods based on the information that is given. So one way to do it is to consider all the corresponding pairs of sides that have this, whether they have the same ratio. So this is called SSS because all the sides will be, in this case, 3 sides. So it's side, side, and side. Yeah. So to check whether they are similar, we have to find out the first corresponding side, which is the base length of the 2 triangles. So 12 over 4 will be my sort of like my first ratio, or that's the first factor. And then if I am dividing the bigger, the length of the bigger triangle with the length of the smaller triangle, I have to keep it consistent for the rest of the equation. So the second one, we are actually considering the left-hand sides of the triangles. So this will mean that we have to use 7.82 first, divided by 2.61. And then because SSS uses 3 sides, we have to consider the third side, which is the right side, which is 11.35 divided by 3.78. So all of them will sort of produce a value of 3. So that means that the triangle ABC is similar to the triangle ADE. Yep. Another way to prove or to test for similarity is using side angle and side. So that means that there will be 2 pairs of corresponding sides that have the same ratio and 1 equal pair of corresponding angles. So I'm just picking randomly 2 sides. So I picked the bottom length. So that means that that's 12/4. Um, equal to the left hand side, which is 7.82 divided by 2.61. So they actually have the same value. So they actually have the same ratio. Yeah. So, and I've picked angle B and angle D, and they also have the same angle length, and therefore triangle ABC is similar to triangle ADE. So the third way to do this is to consider all the corresponding angles, whether they are equal or not. So this will be angle, angle, and angle. So if I consider the first corresponding angle, 66 is actually equivalent to 66. And if I consider the top angle over here, 75 is equal to 75. And the angle on the right will be 39, and this angle on the right is also 39. So they are all equal, and therefore two of the triangles are similar. Yep. Let's just do a question here. So the question is, what is the length of EC? So in order to find the length of EC using similarity, we have to look at the first triangle, so which is the top part over here. And it's really common for people to use just the bottom part here, but it will not work because similarity means that it needs to have the same shape. So obviously this triangle and this trapezium doesn't have the same shape, and therefore we can't use the sort of like the idea of similarity in this case. So what we need to consider is actually the large triangle that's over here. Yep. So if I've copied down all the relevant information, the first thing that I have to do is to find the length of AC. So we know that to find the ratio, 12/4 will be equivalent to AC divided by 3.78. So by finding out the value of AC, which is 11.35 centimeters, we can then sort of answer the question about the length of EC, which is just AC, which is the whole length, take away 3.78, and therefore the answer is 7.57 centimeters. So that's the end of the lesson. Stay safe, everyone, and see you next time. Bye.